Okay, let's take a look at how we can expand our KIM-1 above 8K using a 27C64 EEPROM. Let's take a look at how that has to be wired up. Let's start by placing VCC, PGM, and BPP to the positive rail and NC and ground to the negative rail. After that, we'll wire up our data lines and our address lines as before, with only one exception. Output enable will be going to pin W. Now let's take a look at how that gets wired to our KIM-1 using our expansion connector. As you can see over here, our data lines are at pin 15 down to pin 8, and our address lines start at A and go all the way down to P. You'll notice we're now using address bits 10, 11, and 12 to address the full 8K. Down here at pin W, which is our read-write not, we're tying that to our output enable on our 27C64. While addresses AB 13, 14, and 15 will go to our external 74145 decoder so that we can decode anything above 8K. So now it's time to take a closer look at our 74145 and see how that gets wired up and how it works. Let's start by putting VCC to the positive rail, input D and ground to the negative rail. As you can see over here, our AB 13, 14, and 15 get tied to the input lines A, B, and C of our 74145. One of our output lines, output 1 through output 6, will be connected to the chip select of the 27C64 to determine what range of addresses our ROM will be seen at. Output 0 goes back to the application connector so that anything below 8K will be addressed by the onboard 74145. And output 7 here goes back to the application connector so that our reset will continue to function correctly. Okay, let's take a look at the small wiring diagram on the right showing our 27C64, whose address lines and data lines are all connected to the expansion port on our KIM-1, as is output enabled, which is connected to pin W. We also have address lines AB13 through AB15 coming from our expansion port to our 74145 at inputs A, B, and C. Our 74145 only has two wires heading back to the KIM-1 using the CORSHAM application board. The first one is connected to output 0 of our 74145 and goes to JP5 pin 10 of our CORSHAM application board. This is used to activate the onboard 74145 when addressing anything in the first 8K. The second one is connected to output 7, which goes to our CORSHAM application board at JP5 pin 8. This is used to set the reset vector that is stored in the 6530 riot chip. One final note here is you must move jumper J1 to external on the CORSHAM application board. This removes the ground that's placed on the onboard 74145 at pin D and allows our 74145 to control it. Now let's take a look at our breadboard project and change the chip select on our 27C64 to the various outputs that are available on our 74145. So that we can see the various address ranges that our 27C64 can be addressed at. Okay, as you can see here, we have our chip select going to output 1 or 8K1. So our ROM is being addressed at 2000. Now I also programmed these to show up, I think at every page, I'm not sure. So 400. Yes, so you can see I have it at 2400 or 2400 and 02800. And how about 02C100? There you go. Again, it's that. So, and at the very end, which would be 03FFF, I put a 00 at the end of my ROM. And then if we go one more than that, you can see we're at the next chip select, which would be 8K2, that starts at address 4000. So let's turn that off and move our chip select to the 8K2 and see if that one's working. As you can see, our ROM is no longer being accessed at 2000. So let's go to address 4000, and there it is. As we have our chip select going to chip select 8K2, we should see it at 4000, which is we are. Okay, now let's do 4400, and there it is again. Only because I programmed the ROM to be there. And address 4800. Again, it's there. And address 4000C100 is there. And of course at 5000 should be there too. About 5400. Yep. 100. And 5000C100, and then at 5000 FFF we got our 00. Okay, let's move on to chip select 8K3, which should show up at address 6000. So it's not at 2000 anymore. It's not at 4000 anymore, but it should show up at 6000. There we go. And we'll just cut through a few of these and go straight to 7000. There it is again. And then we'll just go to 7000 FFF. And there's our 00 at the end of our ROM. Okay. Let's move on to 8K4, which should start showing up at 8000. Let's look at 6000 first. No longer at 6000, but it is showing up at 8000 and at 9000. And at the end of our ROM at 9000 FFF. There's our 00. Okay. Now we can go to output 5 or chip select 8K5, and we should see our ROM showing up at 8000 or A000. Let's go straight to A000, and there it is. And we'll go to B000 again, also there. And then we'll go to the end of our ROM at BFFF, and there's our 00. And just one more to go here. It should start at C000 on output 6 or chip select 8K6. Okay, let's go to our ROM at should be addressing at C000. And there it is. And we can go to D000, and again, it's also there. And at DFFF is our 00. Now, what we can't do with our current setup is go to E00 and onto FFFF, because our output 7 is heading back to the onboard 74145 to address anything below or anything within the first 8K. So I guess to get to E000 and FFFF, we would have to add another 74145. But anyhow, I hope you enjoyed this dedication or tribute to our friend at Commodore History who brought this content to us. Again, thank you very much.